Hello everyone, welcome to all of you in this video. Today I will demonstrate this that is the enhanced photogalvanic effect in the two-dimensional WTe2 monolayer bivacancy and substitution doping, in which I will create this structure and also try to doping into this structure of gallium, and after doing this I will calculate the parameters of this structure like band structure and many more properties I will try to calculate. So into in the process of the getting the started this video, I will go to the our device studio user interface now. So I will create the new project. So click create new project. Okay. And I will save this project. So I will save this project with name W and click save. You can see WP, this is our user interface in which using this user interface we will try to create the structure, and our software that is nanodical will calculate the parameters and also try to get the some analysis of this device. So I will take this, I will try to get this molecule from the import online option. So I will go import online and type W, click enter. See, as you all can see, there is a lot of files are shown here with different space group. We have to select the this this T4W2. So click add and expand it. As you can all see, our this is our molecule structure. Now we have to delete one. So I will delete this molecule. So here a tool that for delete. Select it and click delete and try to make this molecule into the center part. So I'll select center, and now I have to try to change their orientation. So from using this tool you can change their orientation as well, and if you wanted to change their alternate axis, so you can change from here. And now you can all see this type of orientation of molecule we use it. So now we have to go to the build option and click redefine crystal, and you have to select some value, right? I will select this value 2 and 1 and click preview, and you can all see and click build option, and now we have to, we wanted to see in this way this data. So now okay, now This is our molecular crystal. Now we have to expand it into, do it again from the redefined crystal, go to the redefined crystal, and we will take this value, the axis of x 3, and this will be 8, and click preview option. Now you can all see, and I will click build. Now this is our which we are shown from this paper. So now we have to, this is our molecular structure. Now our next step will be try to get do some doping and also create this to molecule crystal into the device. So we have to we have to add some atom doping. So doing the doping here, we use the doping. So this is our W atom. Here we will try to add another atom. So here you can see this is a replace atom. When you click the replace atom, your periodic table for all type of elements are open. Now I will select the gallium and click OK. So now you can see this is our gallium doping is completed into this device. So this is the device is ready for, now we have to doing the depth doping. So we have to do the doping into this structure, molecular structure. So we'll select the atom. We have to do doping. So first we have to do this into the center, and this is the center is set it, and this will be a, in this at this W atom, and there is this element will replace the atom. So when you click the replace atom, and here your periodic table is open. Now I'll click on the gallium and click OK. So as you can all see, this is the gallium atom is doped into this molecular structure. Now I have to delete some atom as well also. So I have to delete this. So here this is the delete option. So using this, now we deleted this atom. So to the next part, we have to make this structure into the device form. So I will change this view like this. Now I am going to the making this device. So we'll go to the build option and click on convert to device option, and I will take the you can you, as you all know, this is our convert to device tab, and you can also according to your convenience you can take the electrode as well. I will take the electrode like bottom and top electrode here, as you can all see, and default value is already saved, and you can click on preview option. When I click preview, as you can all see, this the electrode is ready. Now I'll click the build option. So this is our device we are making. Now we have to, now our device is ready. After the ready the device, now our next step will be the calculate the analysis. So we'll go to the nanodical, click nanodical. As you all know, before the calculating the parameter, we have to calculate their SCF calculation. So go to the SCF, and for this is for the device. So here write the SCF calculation for device. You can change their electron temperature value, energy cutoff, exchange coefficients, and K point sampling. And if you have some specific type of values, like I have this value 1, and if you have a contour integrals, this value will be for exchange correlation will be same, and for contour integral you can go from electrode voltage into this device. So you will go to the this and change the value as well. And in iteration control, you can change their mix rate value and give the energy from here, and set the basic set. You can see the energy atom. You can arrange the element and atom as well. You can also select the Hubbard terms if we wanted to change their if you wanted to get data into the spin type values, like uh, collinear and general spin. You can select from here. Now after this you can click generate file. Now you can all see this is the electrode files are ready. So and device file is ready for SCF calculation. So go to the top electrode and click run, and bottom electrode click run, and device to right click and click run. Okay, your calculation is, you can see in the job manager, you can see their calculation status is shown here, which is in running condition. If you wanted to see the data of the input, you can right click open with. As you can all see, this is your SCF input data which you select from this calculation. Here are values are the mentions are here, their basic setting, their iteration control, and which type of correlation you use. Like we use the LDA DZP, that is the local density approximation, and double zeta polarization. Okay, and their iteration control value, which is a mixed rate in which 0 point plus is selected, and its temperature is 100 Kelvin and temperature 80 Henry. This all type of values are shown here. This bottom and top electrode are same, and so the input file will be same here, as you can all see. And in the device, you can see the values for the device input. You can see this is like what quantity should be calculated here, that is the SCF. And for basic setting here, it's temperature, energy cutoff, exchange correlation value, K point sampling value, and here its electrode value as all seen here, like number of leads to how many, means it defined the how many leads, how many electrodes are there, that is 2. And this shows the bottom electrode, and voltage is 0. We are not applied the voltage here, so both values are 0. And their path of the mat file which is generated here will be shown here, and contour integral are shown here, and this is the iteration control in which 0 point mix rate is shown here. And after doing this, this is the basic set in which all type of atom which we are giving here, which as you can all see, our gallium is also shown here, having the exchange correlation LDA DZP, and many more of all the atom are shown here. Okay, so in the meantime, you can shown here, after this one calculation will be calculated, the next will be calculated, and after the second one is completed, then third one will be started. So in the meantime, we will try to calculate the another parameter. So go to the simulator option, nano decal, and click on analysis. Now we will try to calculate the transmission. So in transmission, and we wanted to solve the effective potential, total energy, scattering state, charge, electron density, like density if you wanted to see the electron density, and if you wanted to solve the potential, and many more property. If you wanted to also calculate the conductance, you can select from here. Or if you wanted to calculate the Seebeck coefficient and also density of state, that is zeros. Okay, now I'll select this parameter and I will calculate this all parameter for this device. So I will go on transmission. If you wanted to so change their key point sampling, you can give their value, and here the total number of energy points are shown here. This is the energy range. I will select the energy range which is will be minus 4 comma 4, so the calculation will be some more shorter. And in effective potential and total energy, and this is the scattering state, you can see, choose there also k point sampling and an energy point. This is a charge. If you wanted to see the charge uh, by element, atom or orbital, you can select from here. You can select the electron density, like if you wanted to see the electron density of charge, total electron, row, band, redistributed, as well as all, you can see these things. And if you wanted to calculate potential data like effective potential or active potential, exchange correlation, and neutral atom as well, you can see from here. In conductance, you can see the k point sampling and Seebeck coefficient. You can select the parameters of energy ranges and temperature ranges. This is the interval, how many interval you wanted to give, and this is the temperature and density of state. After doing this, you will click on generate files. When you click the generate files, you can see they're all scf.input file are shown here. And after doing this, in the meantime, I will try to calculate them all to run it. And for the effective potential run and total energy and scattering state, and right click on charge and run electron density, run potential input and conductance input and Seebeck input, density of state. As you can all see all the calculation in running condition. After the calculating, I will show the result. So now my org now my all calculations are done. So I wanted to show the result of this device. So first wanted to show the transmission input. So I will, since after the calculating the result, they are .xml file, that is the visual interpretation for this calculation is generated here. And I will click on right and click show view. So you can see this is the transmission graph, which is a transmission coefficient versus energy graph. And if you wanted to see data into the some specific ranges, you can select the data as well, and you can also zoom it according to your convenience if you wanted to see the data in some specific ranges. So, and if you wanted to see the charge, and I will show into the MATLAB. So if you wanted to total electron density, you can click show view. Okay, so this is the total electron density. And this is the, now if you wanted to see data into the 2D model, you can see here. If you wanted to see data into the along the y direction, z direction, you can select from here. And if you wanted to see data into the stereoscope display, you can click here. And this is the stereoscope display of this data, and you can click 1D graph, as you can all see. This is the total electron density graph, Z versus energy. And if you wanted to see the data into the YZ plane, you can select from here. And if you wanted to see this data into the Z XZ plane, you can click here. Okay, so as well as if you want, now we have to I wanted to show you effective potential, so I'll click on effective potential, right click, show view, and let shown here. So this is the effective potential. So here you can see the this color is changed, that means there is some effectiveness of our shown here. And if you wanted to see the data into the 2D model, so here this is your 2D model of this device and their effective potential as well. And now this is the stereoscope display. If you wanted to see, okay, this is the plain display. If you wanted to see this data into the along the y direction, along the z direction, and if you wanted to see this stereoscope display also in x, y, and z direction, you can select it like this. And after doing this, if you wanted to see this data into the 1D graph, you can select from here. And this is the 1D graph of this effective potential, and click YZ plane, XZ plane. Okay. If you wanted to see this data into some specific ranges, you can select from here. And if you wanted to save this graph or import any of them, which you are seeing here, here option of export. You can see this is the export tool, and you can select it, and where you wanted to see this data, this image will be saved in the PNG form. You can save. Okay. Now here we also calculated the density of a Seebeck coefficient. So I wanted to show the Seebeck coefficient. I'll click on it and right click and show view. After doing this, you can all see. Now this is the blue line will be for the spinner, and red line will be for the spin down. And this is the sigma versus temperature graph. And if you wanted to see this data into the Seebeck spin and charge coefficient, so you can select from here. And if you wanted to see this data into some for specific voltage, you can select from here. Like if you have to wanted to see the graph of for 0.96, and untick the another and select that 0.96, that will be the shown that data. And after doing this, you can, if you wanted to see this data into the chemical potential energy, so as you can all see, this is the chemical potential energy graph. And now as it, if you want to like this, and if you wanted to see this data into some specific ranges, you can select from here. And if you wanted to now, if you wanted to see this data for the specific color, you can select the color as well. And like this. So if you now next we moved on the density of state. I will click on density of state and click show view, and you can see this is the density of state data, okay, for this device. Now you can see the this color are shown for the different atom. And if you wanted to see this data in the specific range, you can select from here. And if you wanted to select some see the data for the specific atom, you can check the atom from here. Okay. So now the next part will be, now we wanted to see this raw output of the this calculation into the MATLAB. So if you wanted to calculate some, so I will go to the MATLAB. I will open the MATLAB. Now I am on the my MATLAB tab, and I locate the file directory where I saved this project. Here you can see all outputs and their mat files are generated here. Now we want to see the raw output of the this our calculation which we have calculated. So first I will go for the total energy. So load the total energy and type data. When you click the data, and there this is the total energy for that device we have made it. And like if you wanted to see the data of transmission dot mat file, you can click the data, sorry, and type data. When you click the data, their log files are shown here. If you wanted to see the like if something data into this, you can simply type like I have to type the data dot description. See, this is the data dot description value in which all things are written form of this all description of this transmission dot mat file. Now I'll go to the total density. So I will click load the total density and type data. And you can see here I'll type the data. And if you as well as you can see the scattering state and type data. Now this data for the scattering state for the density of state. Load it and type data. Now this is the data for the this density of state. If you wanted to see the energy points, you can select type data dot this energy points. See the all the energy points are shown here, which take this in the calculation. Or someone wanted to see this another thing, they can type data and type the first these letters. They can see the data as well. Now for the conductance, I will type the and load the conductance and current module and type data, and you can see and type this is the these files are shown here and type data dot conductance. Click enter. This is the conductance output. This is the DC conductance output for this device we have made it. Now if you want to see the total charge, so load it charge, type data. So as you can see, this is the total charge density, all things are shown here. And if you wanted to see another thing, you can simply load it all and type the data. Thank you everyone to watching this video.